Hey guys, Mr. Milton here. Today we're looking at solving quadratics by factoring. At the end of this video, you should be able to solve a factor a quadratic, and you should be able to solve a quadratic by factoring. Okay, so far we've learned 3 ways to solve a quadratic. We learned graphing, using square roots, and completing the square. Okay, all right. In Unit 7, polynomials, we spent a good amount of time factoring a quadratic into the product of 2 binomials. Could this help us with solving? Could it? Could it? Probably. That's why it's called factoring notes. Okay, so if 2 numbers, big idea, we have to talk about the zero product property because we're going to be plugging this in as a way to get to a solution. If 2 numbers multiply to equal 0, then at least one of those numbers has to equal 0. Okay, basically if A times B equals 0, then either A equals 0 or B equals 0. Okay, how does this apply to factoring? Well, when we had x squared, if we have x squared plus 5x plus 6, right, we can break that down into 2 factors since A is 1. Looking for 2 numbers that multiply to give us 6 and add to give us 5, and that's 3 and 2, right? Since A is 1, we have x plus 3 and x plus 2. Rewriting x squared plus 5x plus 6 into binomials looks like this. If x plus 3 times x plus 2 equals 0, since they're being multiplied and the product is 0, at least multiplied. One of these numbers has to be 0. In this case, either A, x plus 3, or B, x plus 2. One of these things equals 0. Okay, and so either x plus 3 equals 0, x plus 2 equals 0. When you solve both of the equations for x, you have found the solutions to the quadratic. Okay, and solving that shouldn't be too bad at all because we say, hey, maybe x plus 3 equals 0. What would that be? X equals negative 3. What if x plus 2 equals 0? Solve that. X equals negative 2. Okay, those are our solutions. So let's do that with a couple of problems here. We have x squared minus 10x plus 16. Okay, A is 1, really nice. Looking for 2 numbers that multiply to give us 16 and add to give us negative 10. Those 2 numbers were 8 and 2, negative 8 and negative 2. So we have x minus 8 times x minus 2. We rewrote this left side equals 0. Okay, so we multiplied 2 numbers. 1, 2 numbers, and the answer is 0. So either this number is 0 or this number is 0, or both of them. Okay, so we find out what our values for x would be. Add 8 to both sides, x equals 8. Add 2 to both sides, x equals 2. Okay. Next problem on the other side. Same kind of thing. A is 1. Great. Looking for 2 numbers that add to give me 9 and multiply to give me negative 36. 18 and 2, 9 and 4, 6 and 6, 12 and 3. 12 and 3. There we go. Positive 12, negative 3. Okay, and so I have x plus 12 times x minus 3, that's the way that I've rewritten this left side, equals 0. So either x plus 12 equals 0 or x minus 3 equals 0. And again, it's because if I'm multiplying 2 numbers and the answer is 0, one of these has to be 0. Okay, and so we just solve. X equals negative 12, x equals 3. Okay. Remember that the solutions are not the same as the factors. Okay, so they've been really close here. It's not always even really close. Okay, so don't find these x things and say, oh, plug it into the answer. Okay, it's not how it works. All right, let's look at some more examples here. It says solve each by factoring. Okay, first, notice in this first problem that we only have 2 terms. Okay, so we don't necessarily need to use the X box method. When we can factor this out, we see, hey, there's a GCF. We should always check for a GCF first, okay, even if there are 3 terms. So you factor out that GCF, we're left with x times x minus 7 equals 0. And this throws people off, but again, it's just 2 numbers, x minus 7, multiplying each other and get the answer 0. So either this first number, x, is 0, or the second number, x minus 7 equals 0. And we solve. First one is actually already solved, x equals 0. Second one, add 7 to both sides, x equals 7. Here are our 2 solutions. Number 2. Number 2 is written a little bit differently than we've seen, but remember that when we solve quadratics, generally we want it to equal 0, okay, outside of completing the square. And so we want to make this 0, and we'll do that by moving the 12 to the other side. Okay, remember, we don't just pick it up and move it. We have to do inverse operations. So we have x squared plus x minus 12 equals 0. Add 12 to both sides. X squared plus x, nope, I said add 12 to both sides. Why am I saying that? Okay, so now that we have that there, we are going to erase that, erase, okay. Equals 0. So now we can use our x, find 2 numbers that add to give us 1 and multiply to give us negative 12, and those numbers are 4 and negative 3. So x plus 4, x minus 3 equals 0. And then we just solve both equations. Either x plus 4 equals 0 or x minus 3 equals 0. And so x will equal negative 4 and 3. Number 3. Hopefully you recognize this. A perfect square here, perfect square here. See if we have a special case. 2x, 5, positive. Does it work out? 2 times 5 is 10, 2 times 5 is 10, 20. All right, it does work out. Okay, if not, you'd have to make an x. Try to find 2 numbers that multiply to give you a times c, which is 100, and add to give you b, which is 20. That's 10 and 10, and do your box method with your values. Okay, we'll probably run into that. All right, so here we have it. 2x plus 5 times 2x plus 5 equals 0. And it's kind of the same thing, but we just solve it. 2x plus 5 equals 0. One of these has to equal 0. Subtract 5 from both sides. We get 2x equals negative 5. Divide by 2. X equals negative 5 over 2. Okay. Number 4. As we look, we're like, oh no, A is not 1. It's going to be so tough. But before we panic, make sure you check for a GCF. Okay. So there is a GCF here. All these are factors of 3. So we're going to factor that out. X squared plus 7x plus 12 equals 0. Okay. All right. And in terms really of like the 3, we can kind of cancel that out, right? It becomes 0. Okay. So now we're looking for 2 numbers that multiply to give us 7 or 12 and add to give us 7. And that's 3 and 4. So we have x plus 3 times x plus 4 equals 0. So either x plus 3 is 0 or x plus 4 is 0. Solve, and we get x equals negative 3 or x equals negative 4. Excuse me. Okie doke, let's look at number 5. Number 5, 9x squared minus 16 equals 0. Okay. So a difference of squares problem here. Okay, 9 is a perfect square, 16 is a perfect square, there's a minus in between. So another special case that would be helpful if you recognize. 3x minus 4, 3x plus 4. We rewrote this left side equals 0. So 3x minus 4 equals 0. Or 3x plus 4 equals 0. Solve. Add 4 to both sides. 3x equals 4. That must mean that x equals 4/3. Subtract 4 from both sides. 3x equals negative 4. That must mean that x equals negative 4/3. Okay. And the final problem here says 3x squared minus 2x minus 21 equals 0. So looking for GCFs, they're not there. No other kind of way to simplify. So now we have to use the x box method to simplify. In our x, we're looking for two numbers that multiply to give us negative 63 and add to give us negative 2. Okay, remember, because it's a times c. So those two numbers, 9 and 7, or 7 and negative 9. Let's do that. Okay. Now, because a is not 1, we weren't able to take out the GCF like we were able to do in problem number 4. We have to do the box. Okay, and if you didn't recognize the perfect squares earlier, then this isn't your first time, but if you did, this is. Okay, so in our box, first term, first box, 3x squared. Last term, last box, negative 21. And then the other two terms that we came up with, 7x and negative 9x in the other two boxes. We'll go through each row and each column and take out the GCF. Okay, and so we have our two factors. We can rewrite that first side. X minus 3, 3x plus 7 equals 0. And then we're back to our zero product property. One of these two numbers has to be 0. Either x minus 3 is 0 or 3x plus 7 is 0. And so we add 3, x will be 3. Subtract 7, divide by 3. And so x equals negative 7/3. Okay, what other method could you solve number 5? Maybe you're looking at number 5 like, hey, there's no b. Can we please use square roots? You could have used square roots. Unless the problem said, hey, solve by factoring. And then you really don't have the choice. But if you had just, a quadratic you were trying to solve on your own, you could have done that. All right. There's another method we could learn for number 6 as well, which we will learn next. Okay, let's look at this last problem. It says the length of my desk is 3 feet more than the width. If the area of my desk is 28 feet squared, what are the dimensions of my desk? So rectangular desk. Skibbity-doo. And it tells me, we know that we find the length, or the area by length times width. This is W since I pronounce it that way. All right, so we know that the area of a desk is length times width, or base times height, however you want to think of that. But it says that the length is 3 feet more than the width. To solve this question, we want to rewrite that and say, hey, maybe we just write this side as W plus 3. Length equals W plus 3. So when we find the area, we'd say length times width, or W times W plus 3 equals 28. As we multiply through, get everything done, we get W squared plus 3W equals 28. Subtract 28 from both sides. We get W squared plus 3W minus 28 equals 0. Okay, and now we got to break this down to rewrite it to get our factors. Okay, and so as I get that here, looking for two numbers that multiply to give me negative 28 and add to give me 3. Those two numbers are 7 and negative 4. So I can rewrite this side as W plus 7 times W minus 4 equals 0. And then I solve for both of those. Either my width could be negative 7, negative, or my width could be positive 4. Now, typically I say, hey, write two solutions, right? But in this case, I'm not going to do that because this doesn't make sense. If I said, hey, how long is my desk? You say negative 7 feet. There's no negative distance. So the width has to be 4 feet. Our length will be 7 feet because, 4 times something equals 28. and that has to be 7. Okay, but we wouldn't say -7 for our length and -4 for our width. Okay, or vice versa. Okay, so there we have it, solving by factoring. We have one more method to go. See you.